Good morrow, fellow humans. My name is Sean and I am obsessed with infinity. So join me as I attempt to unpick the infinities of what is. Most of us will have attempted to visualize our place within the universe at one time or another. But apart from humbling ourselves, what are the real benefits in doing this? And what are the potential uses of this understanding in relation to our understanding of self? What many of us fail to take into consideration when pondering this immensity of space is that our place within the universe is made up of far more than just a concept of where we are. The other thing we must consider is when we are, two sides of the coin needed before asking what we are. We can usually appreciate, on some level, the concept of infinite space. Personally, I find it much more difficult to imagine a finite reality. However, the idea that I now wish to begin dissecting is that a truly infinite reality must, by its nature, have the potential to be experienced from an infinite variety of perspectives. So let's start by dissecting the next most obvious dimension of perspective, time. Everything we've visualized thus far, regardless of its unimaginable grandeur, has merely been a snapshot, a single moment in time. And so if we continue to unpack the question, how, what we find is that even the briefest history of time will be enough to blow one's mind. But again, it's fun. In the beginning, or so they say, there was the before the before. This begat the singularity, which begat a silent and invisible bang, which begat space-time, the original Adam and Eve. Within the first measurable moment, being the time it would take a photon travelling at the speed of light to cross a distance of one Planck length, known as Planck time, everything that the universe is, was, and ever will be, was. And it expanded. At temperatures of 100 million degrees, 10 to the power of 32 degrees Celsius, it expanded, becoming all of space and time. An infinitely dense singularity, expanding infinitely into infinity. And as the infant universe expanded, temperatures rapidly dropped, falling more than 10 quadrillion degrees across the next 10 to minus 12 seconds to 10 to minus 6 seconds, as the first quarks, electrons and neutrinos began to take their place on the universal stage. And by the time that the universe was a wholly ancient 1 second old, it had dropped another trillion degrees, allowing the quarks to slow, finding their equilibrium when, in a moment, they combined to form the first protons and neutrons. Across the next minutes of the universe's birthing, temperatures fell another billion degrees, allowing nuclear fusion to combine protons and neutrons, giving rise to the first nuclei of the first and simplest atoms, hydrogen, helium, and lithium. Until enough was finally enough, and at about the 20th minute, as universal temperatures passed their tipping point, nuclear fusion ceased. By which time, almost all hydrogen nuclei, being the most abundant element in the universe today, and making up not only 75% of matter in the universe, including dark matter, but also the very subatomic structures that create up to 10% of your own body right now, were already in their present-day form. Everything that is the you of now, the you of the past, and also the you of the future was, in one form or another, here. You were not only at the birth of the universe, you were the birth of the universe, and technically, you still are. But then, for the most part, it was done. The party was over, and the following thousands of years settled into a slow cooling as the sea of opaque radiation grew. In silence and in total darkness. And as the hot plasma soup cooled, it danced. For 240,000 years it danced, pitting photons against other charged electrons and nuclei, while still the universe grew. And stepping sprightly into its 300,000th year, with temperatures now as low as those found on the surface of the sun, electrons finally found themselves capable of being caught in the orbits of nuclei, allowing photons to travel freely across the then 45 million light-year stretch that was to become the observable universe that we see today. Meaning that for the first time since time, the universe was transparent. This began the first of the Dark Ages. There the adolescent universe sat, for 150 million years, in cold, quiet darkness, whilst gravity began its slow and deliberate game. Until one day, around 300 million years after the Big Bang, as the growing mists of simple atoms collapsed upon one another under the ever-growing influence of gravity, a remnant of the universe's younger self sprang back into life, as the first quasars converted the lifeless atomic sea back into hot, active plasma, thrusting it into life once again with the birth of light and the first stars. Supermassive blue giants. It's an amazing story, captured and written down by some of the greatest minds across all recorded history. But as beautiful as it may be, it, like our earlier topic of scale, well, it can be hard to wrap your head around. So in order to gain some perspective of how long time has been, let's reuse and expand upon a famous visualizing tool first popularized by Carl Sagan in his book Dragons of Eden, the Cosmic Calendar. The simple idea of the calendar is to condense the entire 13.8 billion year history of the universe, starting from the Big Bang through to the present day, into a single calendar year, with the Big Bang happening at midnight on the morning of January 1st, and the present day happening at midnight on the eve of December 31st. At this scale, 1 second represents roughly 437 years. 1 minute is 26,250 years. An hour is 1.5 million years. 1 day represents 38 million years. 1 month is 1.15 billion years, and the year obviously is the total 13.8 billion year age of the universe. Beautiful in its simplicity, it describes how everything described above, from the first Planck time to the birth of the first stars, all happened within the first week of the cosmic calendar. As the first stars continue to form and we pass into the second calendar week, glorious supernova explosions fuel an eternal reincarnating of the stars. And as these stars continue to die and be reborn, stellar families begin to cluster, growing ever in number until eventually they begin to form the very first galaxies on January 22nd. almost 1 billion years after the Big Bang. Our very own Milky Way galaxy didn't show up until the 16th of March, almost 2 billion years later. And our own star and solar system didn't form until much later, on the 2nd of September, 6.5 billion years later. Life on Earth began sometime after, on the 14th of September. However, multicellular life didn't take hold until the 5th of December, a mere 800 million years ago. Simple animals took to the waters on the 7th of December, with plants taking to land on December 20, 450 million years ago. The entirety of land-based life on Earth happened in the final week and a half of the cosmic calendar year. Dinosaurs take centre stage on December 25th, with mammals popping up the following day. The dinosaur die out at 6:24 a.m. on the 30th of December, and hominids appear at 2:24 p.m. on the very last day of the year. We domesticated fire at 11:44 p.m. and human history, beginning with the end of the last ice age, began only 27 seconds from the end of the year. The final second of the cosmic year represents all of modern history, stretching back 437.5 years. But what if we now continue into the future? How long can time go on ticking? Using the current most agreed upon theories, let us now move into the next year of the cosmic calendar, starting again at 12 a.m. January 1, now representing the current day. As we move into the future, it is true that the only definite will be change. Yet this is a change already breathing down the necks of our current generations, as they step up to the plate ready to face all that will be in the 21st century. Playing out over only the first 0.18 of a cosmic second, this century will force humanity to come to terms with many paradigm shifts, not least of which a population explosion that will continue to build towards 11 billion people by century's end, and which is already responsible for the 6th mass extinction of life on planet Earth, being the 3rd human-led extinction event to take place since our species stepped out of Africa. The likes of the current event, however, have not been seen since the decimation of biodiversity that occurred at the end of the dinosaurs' reign. And in this light, it's understandable how hard many of us find it to imagine our future in any positive light. However, during this turbulent period, we will also see many great achievements come to light. And if history is anything to go by, humanity thrives in the face of adversity. We will witness the first endeavour of private citizens journeying into space and the moon. And for the first time in the history of life on Earth, we will step on another planet. We will see the completion of the connectome, a digital mapping of the human brain, and this, combined with the exponential advances in computing, understandings of quantum mechanics and the capabilities of AI, we will see the first machines capable of processing data in ways that will surpass even the abilities of the human brain. Less than 2 cosmic minutes into the new year, Voyager 1 will have reached our neighbouring star Proxima Centauri, and at around 38 minutes, the Apollo 11 footprints will have finally faded from the surface of the moon. And if we survive into these following centuries, we will go on to witness the coming and going of islands, the flipping of Earth's magnetic poles, the changing of deserts into tropics and tropics into deserts, the ongoing shifting of continents and much, much more. And all this within the first hour of the cosmic calendar. January 2nd will see Mars gaining Saturn-like rings. And after about a working week lunchtime, the continents of Earth will have recombined into a new supercontinent, making all the lands of Earth one once more. During the first 2 weeks, regardless of humanity's influence, life on Earth will inevitably have to deal with a multitude of cataclysmic events. From supervolcanoes to asteroids, gamma-ray bursts, and even perhaps wandering stars. But regardless of these many battles and their eventual outcomes, by the end of January, with no say-so from the human race, all of Earth's oceans will have evaporated into space, leaving only the most resilient microorganisms to claim the planet as their own. So, yay for them, I guess. Well, at least until early March, when temperatures on Earth will soar beyond any point which life can now withstand. March. Life on Earth has until March. Now that might not seem very far away, but we must remember that in contrast, multicellular life had only come into being on the 5th of December of the previous year, so we still have plenty of time to mess things up. Yet, any interstellar travel or human evolution aside, it will still be a great shame as any future Earthlings will still miss out on the most beautiful of Earth's night skies, as the epic merging of the Andromeda Galaxy with our own Milky Way galaxy begins to take place in April of the new year. This dance of matter will continue to play out in our sky as Andromeda comes into view, growing slowly to fill the sky with all its coming and going of stars, planets and nebula, until it begins to warp the Milky Way around itself, and Andromeda's galactic core begins to dominate the night sky. When, in late June, our sun will begin its core collapse, causing solar temperatures to rise, forcing the sun to swell and expand into a red giant. As it continues to expand into the solar system, it will warp the orbit of our moon to a point where the moon will be literally ripped apart by the increasing gravity and its own celestial tidal forces, living for a brief period as the planetary rings of Earth, before crashing down onto the Earth's surface, as both Earth and Moon are engulfed, or at least singed, by the outermost perimeter of the engorged sun. By the end of June, any future civilization may find refuge further out in the solar system, as the habitable zone moves into the region of Mars's orbit, and then later towards Saturn's moon Titan. But any life left standing by August will watch as the sun begins to cool, losing half of its mass, shrinking down to the size of the Earth, entering its retirement age as a white dwarf. And this is how our nook of the playpen will sit at the end of the cosmic calendar year, when the universe is twice its current age, 27.6 billion years old, and still but a pup. Merry New Year, everybody. Welcome back to The Infinite Now. Welcome to 2024. If you're watching this as it gets uploaded, maybe you're watching this in years to come. But for us here in my current present, it is the first week of this new year, and perhaps that's very appropriate because we just did Carl Sagan's cosmic calendar. Obviously, we're extending his calendar past that first year, which was to describe the beginning of time all the way through to the current day and condense that into one calendar year. We've now done the second calendar year, and coming up next week is going to be, well, I got a mathematician friend to help me with this, but we've extended this cosmic calendar model as far as we possibly can to give you an idea of the unfolding eons, and that's going to be super exciting. I did have the opportunity, as I do each month, to take that chapter and chop it into 3 sections to spread it out throughout the month. Next week, the following fortnight's worth of videos just felt better as one. So you're getting a fortnight's worth of content next week, so it'll be a little bit of an extended video, but do get through to the end because that's where the payoffs are. That's usually the case with all of these things. Jump on, check that out. What we're going to do the following week is maybe we'll have a week off, maybe we'll just do a bit more of a 2-camera unfolding of some of the ideas that we've discussed already in the first couple of chapters. So if you've got any thoughts on that, give me your suggestions in the comments and I will shape the month of content as you guys see fit. The following couple of months are going to be talking about time, and we'll be a little bit more fluid with the structure of how I release it every single week, depending on basically how the chapters feel, whether they're better as one episode or spread out across multiple episodes. That's about it. I'll leave you for now. Thank you again. I look forward to hearing your comments. I really have been enjoying the feedback from everyone. You've been amazing. You've been so lovely. And it lifts me up, gets me back in here working on this every day. I think that's about it. I hope you have a great week. Much love. And I'll see you next week. Bye.